Machine learning is a subfield of AI. As you can see in the figure, AI, if you are considering AI is a very big thing, within that searching is there, learning is there, and also reasoning, planning, acting. These are all the part of this AI tool, but we are only introducing searching and learning now. Searching is a group of activities, is a context where only we are going to find the solution within the database. But with beyond the database, if the solution is available, you need to go for learning practice. Okay, this is the concept I want to share here. Machine learning is a subfield of artificial intelligence that focuses on development of algorithm and statistical models that enable computers to perform tasks without explicit instruction from the human being. Okay, so without any explicit instructions from the human being, it has to produce the answer, it has to bring the solution, like ChatGPT. Okay, ChatGPT, for the case of ChatGPT, you are in the need of giving correct prompt only. Okay, you no need to give any hints or other things, because it is a learning model. We will call it as LLM. Okay, so large language model. So the algorithm itself learn from the past and present experience. Okay, the prompt coming from the user is a input given to that. I mean, it's a command given to that ChatGPT, and it is working, it is updating its learning model day by day. Hour to hour it is updating its learning model, right? So called, what I mean is, we are not in the need of giving some explicit instructions, inputs, clue to that algorithm. Okay, so called, this is machine learning algorithm. Instead, these algorithms learn from data, identifying patterns and making predictions or decisions based on information they process. It can do identify patterns, okay, making predictions or decisions. These are all the what information they are processing. According to that data set, it is capable of doing these things. Learning can able to further classify into two different learning types: machine learning and deep learning. Okay, machine learning is nothing but the simple and I mean, when compared to deep learning, it is simple. Deep learning is nothing but it is, as the name itself, it is deep in learning, right? So some advanced data like multimedia data like videos, high resolution images, our LLM is actually having the deep learning models only. If the data set is somewhat huge, okay, we need to go for deep learning algorithms. And also in with respect to the training methodology, we can also be further classify the learning model into two different types: supervised learning and unsupervised learning. That is not given in here in these slides, right? So you need to understand, with respect to the training process, it can able to have two different types of learning models, like supervised learning and unsupervised learning algorithm. This machine learning algorithm, according to the output it's giving, we can able to classify into two different types: classification and regression. Okay, machine learning, both deep learning and machine learning, both the learning models are having two different kind of algorithms, like classification and regression algorithms. Okay, classification is nothing but it is a one type of machine learning algorithm that refers to the task of predicting the category or class. Okay, so it will give the pinpoint result as 1 or 2. That's all. Okay, for example, dog and cat. Okay, if you are classifying the dog as a dog image as a dog, cat image as a cat. Okay, let us assume we are building an algorithm for this. Okay, if you are giving a cat image, the algorithm has to tell this is cat. If you are giving a dog image, the algorithm has to give dog as a result, right? So this is what we are called as category or class. Okay, so there are different types of, if it is giving only two categories, okay, that is binary classification, multi-class classification and multi-label classification. These are all different types of classification algorithms, right? So for example, okay, if you are taking pen and pencil, okay, and rice and wheat, tomato and apple. These are all the classical examples for binary classification. Okay, what I am going to share here is, in order to classify the pen with the pencil, okay, in order to differentiate rice and wheat, similarly tomato and apple, okay, what algorithm is taking means the algorithm is in the need of some useful informations, especially in numerical data type like features. Even though pen and pencils are the physical parameters, the the algorithm, the machine learning algorithm is in the need of some numerical data. That's all. Okay, that numerical data are technically called as features or attributes. Very important step in machine learning is feature extraction. Okay, so features. What is features? According to this example, pen and pencil, you can able to see here. So these are all the features you could identify. With respect to material, you can classify it is pen or pencil. Okay, with respect to the tip structure, if it is graphite, it is pencil. If it is a ballpoint, it is a pen, right? So these are all the parameters. It is all the attributes of the each category, right? So eraser, availability of eraser, shape of that particular object, color, erasable, pocket insert hook. So these are all the very important attributes uh, of the pen and pencil, right? So with respect to these parameters, if you want to do these things, if you want to do classification between pen and pencil, your algorithm has to be loaded with these information. Okay, pen, that is having material like wood, tip is graphite, eraser is yes available, shape, it is looking like a hexagon shape, right? Color, it is like light brown color. Erasable, yes, if you are writing with the help of this object, it is erasable. And pocket insert hook is not available. So likewise, either it may be yes or no, or otherwise it is a value. That's all. Okay, so this is called features. Okay, the algorithm will study the features and creates a model, and then it is ready for the new data classification. Okay, right? If let us assume a baby, okay, if you are taking a kindergarten child, okay, and telling to classify pen with the pencil, it will automatically do, because it will observe these things. Okay, how it is actually looking like, it doesn't know about tip, okay, but it is somewhat in black color, but it is somewhat in blue, and it is also giving some ink in my hand. Likewise, the child will observe all the things. Okay, so it is not barely looking at the object, it is observing the things. Okay, similarly, the machine learning algorithm has to observe the data. So for that, the user has to extract these things, like I told, right, feature extraction. So by giving these useful informations, the algorithm is ready to learn. Okay, this is the classification from rice and wheat. Yes, of course, color is a very important parameters, and shape and taste and grindingness, everything. So these are all the features or attributes for classifying these two things. And tomato and apple, we know that the textures and the softness, seeds, edibility, color, shape, leaf shapes, everything that having a very important role here. So these are all the features. So what we need to do is, let us assume you are going to build an algorithm, okay, where it has to classify dog and cat. Okay, I'm giving an emoji like cat, it has to tell the result as cat. I'm showing an emoji of dog, the algorithm has to tell dog. Okay, so if you want to develop an algorithm like this is so called classification algorithm, right? So the model has to be trained priorly. Okay, this is the testing phase. Okay, I can able to tell this is the testing phase. Okay, so it has to, the algorithm has to learn from the training data set. Okay, this is so called training data set. Okay, so this is so called lot of dog images, cat images, frog images, every each and every, in each and every class we need to collect lot of data. Okay, we need to extract the features, then we need to give the training. Okay, it has to be labeled properly. Features from the cat has to be labeled as cat. Features from the dogs has to be labeled as dogs. Okay, likewise this is so called labels. This is this is the training phase. It is called as training phase. Okay, after completing the training phase, the model is now ready to classifying the new data given by the user. For this data, the algorithm will extract the same features and it will predict whether it is dog or cat. Okay, this is so called machine learning algorithm. The learning algorithm is ready only after the proper training, right? And this is well known data set, iris data set. Okay, so with the help of this iris data set, we can able to classify the we can able to classify what type of iris flower I am showing, right? There are three different species is available: iris setosa, iris versicolor, and iris virginica. Okay, so even though all the flowers are having the same color representation, but its sepal and petal length and width are somewhat differ from each other, right? So we are going to consider, not we are not going to we should not take color as a feature here, because whenever if you are choosing the color as a useful information, if you are thinking in that way, that will confuse your algorithm. Am I right? Because everything is related to violet or blue color, right? So if you are giving color as an important features for this algorithm, your algorithm will get confused and the algorithm performance will get reduced. So that it is your responsibility, it's users responsibility to give correct features for the training process. Okay, so we are choosing, as you can see, okay, there are some dimensions changes is there. The petal and sepal dimensions is completely different for three cases. So features considered for this case is petal length, petal width, sepal length, and sepal width. So with respect to the features, we are going to find out the we are going to extract the features and then we are going to train the algorithm. Okay, so let us assume this is having different kind of flowers, but let us consider there are only three cases here: iris setosa, iris versicolor, iris virginica, right? So we are going to extract the features. What you have to extract the features in machine learning, you have to learn, you have to extract the feature and you have to do spoon feeding, right? In deep learning algorithm, it is not necessary. For some algorithms it is not necessary to extract the features. Automatically the algorithm will extract the features. Okay, while talking about machine learning classification algorithm, so you have to collect the data sets for the three different cases. I mean, whatever you are going to classify, that number of classes, for that number of classes you have to collect different numbers of databases, right? For example, 50 iris setosa, 50 iris versicolor, 50 iris virginica images you have to collect. Then the collected images has to be given for the next step is image features extraction. From the image itself, we have to extract the features. I mean, manually we have to measure with the help of a scale and we have to give it to the Excel sheet, and this Excel sheet will be the features for the training process, the entire training process. Okay, so with a single block itself we are representing these things, image features. So we need to provide the class labels also, that will create a learned model. Okay, so in order to understand these concepts, what is learned model, right? So our human brain is actually creating a learned model after watching a film, right? So if you are there is a if you are watching a movie like Avengers, right? So after watching the movie itself, you could able to tell about the movie, you can able to review the movie, right? You can able to rate the movie, you can able to narrate a scene in a movie. Okay, you can able to tell the positive and negatives, so called learned model. Okay, before watching that movie, you may heard about that movie, right? Your friends may tell about the movies, scenes, and other things, and BGMs and scene appearance, and all the scenes that are narrated by your friends. Okay, you can able to imagine. That's all. Okay, you are not a learned model. Once after watching that film, you will become a learned model. You can able to tell anything about that film. Okay, if you are really like the film, you can able to give a review. You can able to talk about the film for nearly 10 minutes. Okay, surely you can able to talk about the film for 10 minutes. You can able to discuss the positives and negatives. So called, this is so called learned model. Okay, if you are not watching the film, if I am telling anything from the film itself, I am telling anything positive or negative from about the film, you cannot able to relate what I am talking, right? So this is so called learned model. Okay, so the learned model is having the capability of predicting the future input. Okay, I mean, if I am taking another flower, and I am measuring the sepal length and width, petal length and width, and I am giving as an input to that model. Okay, now the learning model is enabled to give us a class like iris setosa, vesicular virginica. Okay, it can able to give classes like 1 2 3. So this is so called classification. So supervised learning, unsupervised learning, while speaking about these terminologies, this is the image that we are seeing here is supervised learning model. There is a supervisor is available during the training process. He is giving class labels, he is purposefully extracting the features and giving us a training matrix. So this is so called supervised learning algorithm. In subsequent classes, we will see the examples. I mean, we will run the code related to the supervised learning algorithm, and also we will discuss unsupervised learning algorithm. Thank you.